All right, now let's switch some gears into uninhibited growth and decay. A model that gives the number n of materials or cells after a time t has passed is n of t equals n naught, that's what we call that, e to the kt, where n naught is the initial number, so it's the initial value of material or cells that are present, and k is a non-zero constant that represents the growth or decay rate of materials and cells. So a lot of the times in biology, anyone that's going to be taking biology classes, you're going to be talking about cells or bacteria, and those all follow the law of uninhibited growth and decay. So if your k is larger than 0, the culture is growing. And if your k is less than 0, the culture is decaying. And notice that this formula looks really similar to the end amount equals the principal, so what you start with times e to the rate that it's changing times time. These are very similar formulas. And remember, again, the growth or decay rate is a decimal representation of the percent rate of change. So let's look at some examples of this. So let's look at an example of this. A colony of bacteria grows according to the law of uninhibited growth, according to the function n of t equals 90 e to the 0.05 t, where n is measured in grams and t is measured in days. So just to remind us of the formula for the law of uninhibited growth and decay, this is the formula. So n of t is the n amount equals the initial amount times e to the kt. Determine the initial amount of bacteria. So if we match it up with this formula, you can see the initial amount is 90 grams. And make sure that you're putting your units. What is the growth rate of bacteria? So the growth rate is the k value. You can see the k value right here is 0.05. We want to make sure that we're writing it as a percent. So 0.05 is the same thing as 5%. What is the population after 5 days? So this is substituting in 5 for t. So we get n of 5 equals 90 times e to the 0.05 times 5, which is about 115.56 grams. So after 5 days, the population is about 115.56 grams. How long will it take for the population to reach 140 grams? So now we're looking at this n amount being 140. And we're solving for t. So this is just an exponential equation. So we need to isolate the exponential part. And we get 140. And again, I'm not going to reduce anything or substitute this into my calculator until the very end. So now that I have the exponential piece by itself, I can take the natural log of both sides. And that will allow me to move that exponent in front. So we get 0.05t times the natural log of e, which is just 1. So I'm not going to write that. So now to get the t by itself, divide both sides by 0.05. And you get that t is approximately 8.84 days. Again, make sure that you're including these units. What is the doubling time for the population? So doubling time means how long does it take for the population to double in size. So the initial population was 90. So if we double 90, 2 times 90 is going to give us 180 for that end amount. So essentially, what I'm doing is I'm solving for this equation. So again, I want to isolate the exponential piece. So divide both sides by 90. Now that I have that exponential piece isolated, I can take the natural logarithm of both sides. And now I can bring that exponent in front using that power rule. And again, remember that ln of e is just 1. We'll divide both sides by 0.05. And I get that t is approximately 13.86 days. Let's look at another similar example. I really recommend that you pause the video and try to work this example out on your own. And then after you've done that, watch me work through it to make sure that we're getting the same things. Iodine-131 is a radioactive material that decays according to the function A of t equals A naught e to the negative 0.087 t, where A naught is the initial amount present and A is the amount present at time t in days. Assume that the scientist initially has a sample of 200 grams of iodine-131. What is the decay rate of iodine-131? So the decay rate is that K value. So that's going to be negative 0.087. And if I wrote that as a decimal, that would be 8.7%. And I don't write negative 8.7% because we already know this is decaying. So we're just saying what is the decay rate? Well, it's decaying at a rate of 8.7%. And we'll write this just so that you have this in your notes. How much iodine-131 is left after 5 days? So that's substituting in t equals 5. So this A naught, again, is that initial amount, and they told us that the initial amount is 200 grams. So substituting that into your calculator will give you a value of about 129.45 grams. When will 70 grams of iodine be left? So now, this is solving for t. So we know that 70 is the end amount I want. Again, I know my initial amount is 200. I don't know what the time is. So this is an exponential function, so get the exponential piece by itself. So that leaves us with 70 over 200 equals e to the negative 0.087 t. Now that I have that exponential piece by itself, I can take the natural log of both sides. And now that I have this written as a logarithm, I can use the power rule to move that exponent to being in front. And again, remember that the natural log of e is just 1, so I don't need to write that again. So to get the t by itself, divide both sides by negative 0.087. And you get that t is about 12.07 days. What is the half-life of iodine-131? So half-life means how long does it take for this decay or bacteria or material to go from the initial rate to initial amount to half of the initial amount. So again, half-life is how long does it take for it to go from the initial amount to half of that initial amount. So our initial amount is 200 grams. So my end amount, if I'm looking for the half-life, is going to be half of that, which is 100. And I'm solving for the amount of time it takes for it to reach half of that initial amount. So I'm solving for t. So again, I have an exponential function, so get that equation, so get that exponential piece by itself. And that leaves me with 1/2 equals e to the negative 0.087 t. Take the natural log of both sides. And now that I've done that, I can move that exponential part in front. And again, the natural log of e is just 1, so I don't need to write that. And divide both sides by negative 0.087 to get the t by itself. And I get that t is about 7.97 days.